You know, leprechauns were originally evil. Okay, yeah, so that's good time for everyone else to come in. Welcome. Let's make sure this thing's doing captions as well. There we go. And there we are. So we'll stop talking about leprechauns because I confused the caption machine enough as it is. Oh, seems to be doing pretty good. All right, today we're going over 4.2, which is proportions. Hope everyone had an amazing spring break. I know I did. I only got a little more bald over the break. It was great. All right, so a proportion is an equation showing the equivalence of two ratios or rates. There's a lot of big words there. So let's simplify this a little. Let's talk about what is an equation. An equation, this is a Q, is a statement that is true or false, but not both simultaneously. Now, for those who are going, Matt, you said you'd make this more simple. Yeah, that's a lot more simple, right? Let's make it super simple, just in case, this is your first time ever looking at this math. An equation, we just put this sign between two things. And what we're saying is this is the same as that. That's what that symbol means. They are equal. Notice you have equivalence here. That's what it's saying. They are, which I disagree with that. It should be showing, well, I don't know how they should say it, because equivalence, you can have something that's approximate. That's when we put in the wavy equals. That's for approximations. Don't worry about that right now. But what we're saying is an equation, it has to be the same or not the same. It's either true or it's false. It's not true. There are only two options. The sky is purple. That is a statement. It ends in a period. It is either true or it's false. All right, now for a ratio. A ratio is a this to that. We've represented them a few ways in this. So a ratio can be represented like 2 to 5. For every 2 times I punch my brother, he punches me 5. Or 2 out of 5. Notice we have this. This is division. And division, we call it as a ratio. We work all the time in the rational numbers, but we also call them rates. So let's say that I drove to work today and I was in a hurry. Maybe I drove 55 miles per hour. Well, that's the same thing as saying 55 miles over 1 hour. That's a rate that I'm traveling at. So when it says that it's the same as a ratio or a rate, that's because a rate is a ratio. It's a relationship. So when you see rates, if you're like, oh my gosh, my head hurts, just think miles per hour tends to be the most common here in the US. For my friends in the metric system, it would be like kilometers per hour. But that's the way that we look at things, is through standard units. All right. Now, with this idea, a statement is either true or it's false, not both simultaneously. Well, one thing we can say is we can say that if I have some A over some B, which is equal to some C over some D, and of course, A, B, C, D are not equal to 0. If I look at this and I say, okay, you know what? I'm going to multiply this side by D and this side by D. When I do, these D's reduce and I get AD over B is equal to C. Let's make that a prettier B. Now I can multiply both sides by B. And when I do, I go and I have AD is equal to BC. The reason I can do this is the multiplication property of equality, which states I can multiply both sides of an equation by the same non-zero amount and not change the truth value of the equation. So down below, we'll show it as a cross multiplication, but this is the process behind the scenes. So if this is causing you heartburn, don't worry about this. I just want you to be able to see there's a reason why. There is no magic to math. It isn't, oh, the teacher said I could, therefore I could. No, there's no magic in what your teacher's saying. It's mathematical principles that we're applying. So if you struggle with that, don't worry about it. We will get you there. It just takes time. So with this, we'll have the question, is this proportion true? Well, what we can do is we can multiply this and multiply that. And so we have 30 times 4 is 120, which is equal to 2 times 60, which is 120. Is that a true statement? Yeah, so that one's true. That's how we can check a proportion very quickly. We can say, are these equal? So I'm just going to scroll down a little bit. This one, I can see it because I can see this will go to like a 12 and this will go to a 1. And this, if I divided it, would be 12 over 1. That's another way of doing it. But let's look at this one over here that isn't so, maybe not everyone sees it, but to me, this one's not as obvious. I know because I looked at it and went to do it in my head and I got this one just fine. 5.4 times 10 gives me 54. And then I said, 6.8 times 8. And I couldn't just do that in my head. I'd get something wrong. But 8 times 8 is going to give me 64. So 4 here, 6 here. 8 times 6 is going to give me 6 times 8 is 48 plus 6, so 44. And then there's 1 behind the decimal, so I've got to bring that decimal over 1. 44.4. No, that is not a true statement. That is false, a fallacy. That's not true. So we can say, no, that one is false. And just to double check, we'll check with the calculator, 6.8 times 8. That's what I thought. That's what happens when I do math in my head. All right. Yeah. There we go. Now technology's acting up. 54.4. Again, 54 and 4/10 is not the same as 54. Because if I have a bill for $54 or $54.40 and I give them 54, that's not enough to settle my bill. And I'm going to be, where's my 40 cents? Now, the other way we can use this, and I love to use this for is over of, so those of us who've played with percentages may recognize this. You can take and do it here and get an idea what you've got going on. So n times 15, we're going to have 15 n's is equal to 60. And now if I divide both sides by 15 because I want my n alone. I'm always, when I'm solving for a variable, I'm isolating it, getting it away from the group. This time it's grouped by multiplication. We undo that with division or multiplication by the reciprocal. And we get n is equal to 4. So we can use this to figure things out. All right. So if 6 ounces of noodles, 6 to 3 servings, how many noodles do you need for 8 servings? Well, we don't know this, but we could say, hey, you know what? 6 is to 3 is the same as x is to 8. Why do I use x? Because I can't stop thinking about her. Or because it's just a fun letter to play with. I mean, Elon Musk liked it enough to change the name of Twitter. Can't be that bad of a letter. Do you think he did that to spite an X, maybe? Just giving people a moment as they're catching up on their notes. All right, so here I can say, all right, 3 times x gives me 3 x's. 6 times 8 is equal to 48. Now I divide both sides by 3, and I get x is equal to, what is that, 16? This is why we don't do math in our heads, because it is correct this time, but it doesn't mean I'm always correct. Excuse me. Sorry, people at home. Allergy season has moved in full swing. All right. So that's how we do these. We just set them up and this is to that. Okay, now this is where we use proportions here. So on it, we can look at it and say, all right, we have here one side to one side. So here we have 6 centimeters is to 10 centimeters as, and we want the same side. So when this flips, a centimeters to 15 centimeters. And the trick there is they took this shape right here and they flipped it so that it says, okay, this side is here. The hypotenuse is here, and this side is here. This is an example of proportional reasoning in action. So with that, we can use proportional reasoning. This is to that to figure out our unknowns. So notice here it said 8 is to 10 as B is to 15. Again, we're going with the same thing. For anyone who's struggling, if I were to physically pick up this triangle, move it, rotate it, and put it over here, it would just be slightly smaller. This may not be drawn to scale, that's okay. So if I take that and I say, okay, here we go. Now let's see if it'll let me rotate this. The joys of technology and learning it. Oh, it's not letting me rotate it, so that's okay. But if I were to rotate it, that's how this side here becomes this side here. And that's how I'm getting those relationships. I'm lining it up based on that. So on that, A standard wheelchair ramp should have a grade no steeper than 1 to 12. This means for every 1 inch of rise, change in height, there should be 12 inches of run or change in length. So up 1 over 12, rise over run. And if a door is equal to 2.5 feet above the ground, how long will the wheelchair? Now notice this is a trick question right there, because this says for every inch. This is in feet. So let's convert that, shall we? Shall we convert that to 30 inches? Because in 2 feet, there's 24 inches. Plus half of a foot would be 6 inches. So that would give me 30 inches. So we would say 30 is to some unknown. You see the trick there where they didn't use the same unit? This is huge. Anytime you're doing story problems, make sure you're dealing with the same unit. It's like going to Canada and trying to pay with American dollars when they're expecting Canadian currency. Typically, it costs more in their currency. So now we just do the multiplication. 1 times x gives us x, which is equal to 30 times 12, which is 360. That seems like a lot of feet. That's because it's 360 inches. Ah. And the question is, how long would it need to be? So we could divide that by 12, and what would we get? 3 feet? 30 feet? Yeah, we'd get 30 feet. I feel like I've run in a circle there. Makes my brain hurt. Because here we have 2.5 feet. If we multiplied, let's change that to 2.5 and see if that helps. But that's still in inches. That would be 1, that's why. Okay. I gotta stop second thinking, it makes my brain itch. So now I just divide by 12 and we get x is equal to 30. That's kind of funny. All right, on this one, what we're going to do is a this is to that relationship. So we have 8 is to 10. So 8 is to 10, which is the same as, so 8 to 10, which is the same as 17 is to side A. 8 times A gives me 8A is equal to 170. Divide both sides by 8. And we get A is equal to, and we'll just plug this into our calculator. We'll say, okay, 170 divided by 8, and we get 21.25. So 21.25 centimeters. And then we can do the same thing for side B. 8 is to 10, the same as 15 is to side B. So we get 8B is equal to 150. Divide both sides by 8. We get 150 divided by 8. What's that? 18.75. Just make sure on these that you're lining them up right and comparing the right sides to the right sides for your proportions. All right. Ooh, this looks like a question you'd find in trig. To find the height of a tower 40 feet away, you hang a tape measure 4 feet from you and look up to the top of the tower. Your eyes are 8 feet off or 5 feet off the ground. The top of the tower lines up with a point on the tape measure 7 feet off the ground. Okay. How tall is the tower? All right, so why does the height of that matter? Let's have a look here. Doesn't that seem like a tricky question? Because if we were to say from here to here, maybe, that would be a triangle. And then we would have here. So we could draw that triangle and say this side's 36 feet. And then we could say that this side here. I don't know about you guys, but my brain just got lost in the middle of this. Because I'm looking at it going, well, 40 is to 36. Now I have enough to go on for one side. But I need to know another side. I'm going to think on this one and how they're related. Because your eyes being 5 feet off the ground shouldn't be that big a deal. But you hang a tape measure 4 feet from you. So you hang it right here. It's hanging. So it's saying this is what, 5? And then it's saying yeah, so that's what it's doing. What a weird problem. This is kind of fun. So basically what it's doing here is it's saying, look, we can figure out this triangle right here, assuming I can get this line to move properly. While everyone's feeling nice and lost, seriously, what is it with this thing wanting to not draw a line from right there? Do you guys see that? It jumps around on me. It's not me this time. So basically what we've got is we've got a triangle that looks like this, right? Oh my goodness. It's being a Monday. Well, part of it is I took a minute to think about it and I'm like, okay, I'm trying to see how these are related. Okay, so it's saying that we have this triangle here. This side's 36. We can say that it's going to the top there would be about 7 feet. So that would be 7 feet. And from that, we can figure out this one is 40. So we can say 7 is to 36 as some number is to 40. That was tricky. It required me to sit and think about it. It reminded me of my days back in college when I took trigonometry. It was kind of fun. So now we say 36 times x is 36x, and 7 times 40 is 280. Divide both by 36. And we get 280 divided by 36, which is that seems a little weird. What do you think, Ghazi? What do you think? Yeah, how tall is it? Using similar triangles. Because I'm only getting that it's 7 some odd feet, but that doesn't match the picture. The top of the tower lines up with the. Yeah, that's what I did. Yeah.
Divide by this.
Yeah, that's what I did. Oh, you're saying it should be.
Equal this. Or this for this. Why? Because
Oh, Ghazi's saying 4 to 7 triangle would be the same as 40. Okay, so Ghazi's saying, Matt, you did it wrong. Sorry. Ghazi's saying that we know this length here, we know this length here, and we know that length. So he's saying 7 is to 4 would be the same as some number to 40. So that would be 4 times 7 is going to, or sorry, don't do math in our heads, people, even though the answer is 70. 4 times x gives me 4x. You're saying 44? But look, this one ends here. See? From here to here is 40.
young. This 40 from here to here. This is not triangle. Two triangle.
So you're saying to be a triangle? Okay. Right. Right. Yeah.
Bigger and small.
Right. Right.
Small. By this. Equal this over this.
Right. Right. But if you look at the notation on it, Ghazi, it says, so the line.
Yes. This 44.
Mhm.
This 4 and 40. This and this.
See?
44, yes. Oh, this 44.
No, 40.
Yes.
See, it agreed. It has that. See the drawing?
Now, yes. This.
Yeah, see? 40.
This 40 from here to here, I think. To here.
No,
Because
but the
this-
line for it's here.
Oh, yes.
See the
Oh,
line.
this.
Here, let me erase my notations and we'll see. See?
This all 44, 40.
Yeah, see?
It's all 40, yes. And this 4 and this 4 meaning
See, this is
yes,
included.
yes. Meaning 40 over 4 equal this over 7 like this 7.
You're saying 40? Okay.
Divide by over this. Smaller, bigger.
40 to 4 is equal to,
This.
well, we're still going to get to the same place. They're the same, see?
Yes, over 7 over x. Oh, yes, but x. 40.
4 times x is 4x, 40 times 7 is 280. Same. Yeah, that's because there's more than one proportion there. We can line it up. As long as we keep the one triangle to the other the same, we're fine. And so we get x is equal to 70. Either way. Before I was trying to make a similar triangle here, but that didn't work because I was making an assumption. Something we don't do in geometry, people. Assumptions in geometry are deadly. Ask anyone who designs bridges for a living. All right. So any questions? You guys want to do another story problem since these are so much fun? Sure, Matt, we would love to. Maybe I'll get hung up on it. A model car is 1/18th scale, meaning 1 inch on the model is 18 inches in real car. If the model is 11 inches long, how long is the car? 1:18 is the same as 11 is to some unknown. And so from that, we get 18 times. So 1 times x gives me x. 18 times 11 is 198 inches. That one was a lot easier than the other one with the triangles, huh? And don't worry if you don't see this stuff right away. Don't stress it. We can go over it again and again and again. It will come to you, given enough times practicing it. All right, find the distance from Austin to San Antonio. Okay. So on that, it wants to know that if this line is 20, then how many segments of that line would there be? Well, we could measure it. Let's pull out our ruler and see if we can't figure this out. All righty. So first let's get a standard unit measure. And I'm going to go with kilometers because it's lining up nicer. So 50 kilometers is 2 centimeters. So how far is this? 5 centimeters. We know 50 km is equal to 2 cm. So 2 cm is to 50 km would be the same as 5 cm to some unknown kilometers. We get 2 times x. It's going to give me 2x is equal to 5 times 50, which is 250. Divide by 2. And x is equal to 125 kilometers. The reason I chose kilometers, not miles, is when I was lining this up on the miles, notice it does a weird fraction there. I didn't want to play with that. I got a much cleaner measurement here, and that's why I went with the centimeters. So my first step was to write down their legend and say, okay, well, what is this distance here? And I said, okay, it's 1, come on. It's 2 whole centimeters right here. And 2 centimeters is to 50 kilometers. Then I did the measurement of this line and I found that was going to be 5 centimeters. And that's how I set up our proportions. And that's what I thought. See, the story problems always tend to be the most fun. Any questions, comments, or concerns? All right, well, thank you for coming. And if you have any questions, feel free to come in. And notice that on these, sometimes I struggle. Maybe it was us going to spring break. Maybe it was a few other things. Ultimately, I want you to see there's power in the struggle. It's all about having the diligence to finish the problem, to keep coming back, knowing, hey, I can go ask for help if I need to. I had Ghazi have a look at it with me. So thank you for coming.